Hello. Good afternoon, everyone. Maybe here. Hello. Hello. Good afternoon, everyone. I'm Jose. I'm coming from Robert Gordon University in Scotland, and today we are going to talk about SSM. Is a new XML language to represent electronic questionnaires. So the computer-assisted interviewing systems use electronic questionnaires to conduct survey research. The computer-assisted interviewing systems, they usually have 5 stages, in which we are going to focus in design and collection. So the design means describing the features of electronic questionnaires in terms of the content, the questions, and the flow, that is the routing, and also personalization features. In terms of collection, means gathering responses from the respondents. The management stage is like tracking the different surveys ongoing, as well as the responses that you get from the respondents. The analysis is by using statistics, extract conclusions from your results, and reporting is presenting these results in a way understandable by businesses. But the computer-assisted interviewing systems should have a specification language to describe every feature of electronic questionnaires. But the question itself is, why could we use XML to represent survey features? First of all is because it allows defining syntax and relationship among the elements, permits the exchangeability among different computer-assisted interviewing systems, and the most important one is because it could reduce the demands of programmers for defining questionnaires logic. So here is an example of a questionnaire in which we try to represent at least the important features of electronic questionnaires. So intro question allow you to introduce in a new section or end in a section. Single responses, obviously, you can only select one response from the set. A skip is very important. This is a logic. This is a logic to modulate the flow of the questionnaire. Interviewer instruction is something for the interviewers that they never should be prompt to the interviewee. And multiple responses is like you can select more than one response from the set. Piping as well is very important nowadays because allow you to personalize the survey ongoing. Like imagine that you have a question, let's say, do you like, what fruits do you like? And there's apple, banana, watermelon, and the user just select apple. So the next question could be why you like apple. So we are bringing the response from the previous question to this new question. Another features is the grid, allow you to ask to the respondent more than one question simultaneously. Filter is another feature for modulating the flow of the questionnaires. Open-ended questions is to collect verbatim responses and is very used for qualitative data. And loop itself is very important because you don't need to repeat a question or more than one question several times. But before starting to create this language, we explore different alternatives in the market. And the 3 big categories are the content, in which you represent the questions, the routing are the features to modulate the flow of the questionnaires, and personalization features. We would like to highlight that the only standard in the computer-assisted interviewing systems is SSS. And as you can see, it's not able of representing any of the features from routing, which we consider that is very important to describe the questionnaire and the order of the questions. This is the modeling approach that all of them are using to describe the flow through the questionnaire. I will come back to this slide later on. But we have two research questions. How can features in a questionnaire be represented in an XML authoring language? And the second one is, does the hierarchical modeling approach lend itself to questionnaire design and or collection of the computer-assisted interview stages? So we think there are three criteria for modeling the routing. The pre-test allows you discovering problematic questions, and consequently, you can improve the gathering of responses in the collection state. The matching between design and the model means that the designers of questionnaires usually they use skip and filter features. So we should have both features in a language because this can permit the flexibility in terms of design of the questionnaire. And the adaptability is how easy it is to make changes in the system. And we would like to have a system in which the coupling is reduced or is very low. So given these three criteria, we come back to the hierarchical modeling approach. And in terms of pretext, imagine that you would like to test the question 5 that is in the inner part. So first of all, you should run the questionnaire from inf1 question. All the preconditions should be satisfied until you reach the question 5. In terms of the matching design and model, we would like to say that the hierarchical modeling approach, they say that using a skip, that you can use filters to avoid the skips in the questionnaire. Indeed, it's true, because you just need to negate the logic from the go-tos on the skips, and you get the same. But in terms of designers, the designers of questionnaires, usually they are not programmers. So I think for them it could be difficult to understand that it's the same logic reverse. And in terms of adaptability, I think it's quite obvious that the inner questions, they are highly coupled from the other parts. So it's like the inner sections are very coupled. And if you want to make changes in the questionnaire, I think it could be horrible. So this is our approach for modeling the routing. It's based on states and transitions. So if we compare with the three criteria, we could say that in terms of pretext, if you want to test, for instance, from question 5 till the end, you just need to mark the starting of the net in the question 5. As well, this model represents both skips and filters by using the if-then-else statement. And the adaptability or the easy to make changes is just a matter of adding new transitions or adding new stages in the model and the connections between them. We would like to say as well that this approach is based on a directed acyclic graph. So this is the if state that we have in our system to modulate, in this case, the question 1 from the questionnaire, the three go-tos that we have attached over the responses. As well, we would like to say that maybe the expression is horrible because this is postfix notations. The good point with this notation is you don't need to put parentheses to create a prevalence between the operators, because in these notations, the operands go always before the operators. So if this expression is satisfied, we go through the transition sync0 that finish the state, finish the questionnaire, as we can see, go to the end. Or otherwise, we go to the question 2. In order to modulate the loops, we use a for approximation, and it's based on a range. So we have a starting, in this case it's in 0, an end in question 5 because it's asking an open integer question, and the increments is by 1. So if the expression is satisfied, we go to the state C1. If not, we continue to another part of the state model. And the composite state basically is like a function in a programming language that allows you to call to another state transition model and reuse different state models even in between different surveys. But the important things are how we validate XML documents according to our language. So there are two steps. The first step is there are create rules in XML schema definition. And the second step, we use a schematron to define business rules. If also we would like to say that if the first step is not valid, directly we don't execute the second step that check the business rules of the document. So in terms of rules defined in an XML schema definition could be a section of a questionnaire contains a set of questions. This could be intro, single, multiple, open, grid questions. And in terms of the second step, we have things like every variable means question itself, used in a state model, must be defined in a section referencing. Or every transition target must point to a defined state in the state model that you are defining the logic. In terms of the results, we use 15 real questionnaires from Pexel Company. Pexel Company is as well part of the project, and indeed the project is part funded by Pexel Ltd and the government from Scotland. And basically they use questionnaires, paper questionnaires, they transcribe to the system and get the responses from the users in order to get business results. So this graph is sorted descendantly, and in terms of the content, the most frequent feature is the single response. In terms of the routing, we would like to highlight that our system offers both possibilities, skip and logic, and all the questionnaires that we try, we can see on the bar chart that the skip logic is appearing at least more than half than filters. So we should have a system considering both approaches. And in terms of piping, in terms of personalization features, piping is the most frequent feature used. And the good point as well we would like to say is like all the surveys that were represented using our language, all the real surveys that we test. So this is the interface that we use to define questionnaires. This interface is creating XML code in background. And in this example, we are modeling the skip logic attached over the question 1 and also over the question 2. And we can see as well, maybe it's not very visible, but on the question 3, we have add display logic means if you want to create a filter over this question, or advanced features like check computations. In terms of the collection stage, we need to highlight as well that our state transition model is also used to run the questionnaires. So basically, the user, when you receive the questionnaire, the respondent, the question or several questions in the same screen are coming in a JSON format. That this JSON format is obviously the same representation that we have described on the XML. Why we use JSON? We use JSON because we think in terms of JavaScript it's more flexible to deal with JSON objects than XML. And in this case, we are representing the question 1, the single question. And as you can see, the next button is automatically enabled as soon as the user presses something. As well, this client interface is everything is created on the client. Nothing is created on the server. So the JSON data comes to the client, and the client using a framework that is Angular JS represent the question or the question itself. The conclusions, we would like to say that all the XML approaches that we studied, that do not fully cover every features of surveys. As well, the hierarchical modeling approach falls short in terms of the three criteria that we spoke before. And all the construct that we studied could be represented in our SSM system. And last, the state transition modeling that we introduced lend itself to addressing the routing task of the questionnaire that we consider is the most important feature of electronic questionnaires. Thank you.
Thank you very much. So we have time for questions. Yeah.
Do you have an interface for the drafters of the questionnaires? The drafters of the questionnaires, the people coming up with the logic and the logical route.
What do you mean exactly?
I have a use case in mind, a product that we're actually working on, where drafting is rather more complex than just creating a questionnaire. It's the result of the questionnaire that then leads to the next product. One of the challenges we face is that people who have the logic in their head might not be that apt at using an interface. So I'm curious to see what is the interface you provide to people who actually have to create the questions and organize them.
Well, I present a bit this interface, but it would be nice to see a demo example, but we don't have time. Basically, as you can see in this feature, here you can represent the most important feature is like display logic is the filter, like an if then else, to say if it's true, show this question or not. And the skip logic, as you can see, is how often do you use your card? We have here a combo box representing all the responses for this question. And it's just say if the user select never, or if the never is selected, go to the end of the block. With this, we represent the skip logic, and the filter logic is we have an expression builder in which you can use a set of operators that we have defined in our language.
Okay, thank you. Other questions? XML.
That's very interesting, thanks. I am working with the French National Body for Statistics, and they have a very similar project, and they're generating forms, previously in PDF through OpenOffice. I spare you the details, it's pretty heavy, and now in Xforms. But they're using a different format called DDI, Data Documentation Initiative. It's quite ugly format. I would not be using it myself, but they said that it's very good to model all the aspects of the life cycle of a questionnaire. Are you aware of this vocabulary?
Indeed, we are not familiar with this. We couldn't have time to explore this approach. And I think one of the reviewers, he mentioned us.
Yes,
maybe it was yourself.
Again, I am not a specialist of statistical issues, but they say that it's quite widely used worldwide. I think that it's used at least in Belgium, Canada, Australia, France, and many other countries. Yeah.
Thank you.
Any other question? I have one myself about I see little difference with SC XML, which is a W3C standard.
Sure.
SC XML stat. I think it was mentioned also by Jim this morning. SC XML state. I don't know what the C means, but it seems like also state transition things, but it's not related to that. Is there any way to build on top of SC XML, or it's a? I don't know. Okay, so
sorry.
Next step probably. Thank you.
Thank you.